Hey class, welcome to day 2 of week 5 here of remote learning. All right, so far, not a lot of you have finished the notes or the homework, but that's okay. Hopefully you get this done between my recording and class tomorrow. All right, and I know some of the technology yesterday may have been a little bit challenging with being able to take a screenshot, but hopefully my notes were helpful. I added a little how-to, and if you weren't able to get those screenshots in there, please reach out to me so I can help you with that. But hopefully you're at least able to graph them on Desmos and finding the solutions. All right. So the most important part of yesterday's lesson was be able to find the solutions of a quadratic graph or a quadratic function. All right, so today we're going to be exploring these quadratic graphs a little more, okay? We're going to be looking at the different graphs and kind of what happens to them, how they change sizes and shapes and move up, down, left, or right, okay? So if you have not been able to, print out these notes, print out these notes so you can follow along here, okay? And again, if you don't have a printer to print these out, that's okay. I'll kind of just write down some of the key ideas here, and I'll kind of tell you which stuff you should be writing down and what stuff is okay not to write down. And then when you do the homework after this, reference these notes here, right? I always post the key to these notes. Make sure you're referencing the notes when you're doing the homework, okay? All right, so before we get too deep in this, all right, we had a couple of vocab words here that we got to talk about. All right, let me get my drawing tool here. All right, so the first vocab word here is the standard form of a quadratic function. All right, so the standard form, all right, is going to look like this. All right, and we've seen this before, right? It's going to be y equals this ax squared plus bx plus c. Right, we've seen that before, right? And actually, I had this a as in green, right? I had that b in blue, and I had that c in red, right? This is our trinomial here, all right? But when we add that y equals part to it, this makes it a quadratic function, all right? So that's what the standard form of a quadratic function looks like. All right, and then we talked about this word yesterday, the word parabola, right? That is just a graph of a quadratic function. All right, that's like the shape, right? That U shape. All right, and then another word here, another vocab word here is called the parent graph. Okay, so the parent graph is kind of like the starting graph. It's the simplest form of a parabola, right? And your parent graph is always going to look like this here, y equals x squared, right? Because that is like the basic level of a parabola or a quadratic function is just that y equals x squared part. All right, so when we explore our graphs here in a minute, all right, we're always going to include this parent graph so we can kind of see what the original one looks like and then see what happens to the original graph as I do things to it, okay? So here we go. All right, so in example 1 here, right, we're going to be asked to graph all of the following quadratic equations on the same graph using this Desmos app again. All right, so we're going to go to Desmos. All right, we want to start graphing. All right, and we're going to put all 5 of these on this same graph here. Okay, so the first one is y equals x squared. All right, remember to get these extra tools and stuff. I'm going to pull up this keyboard here. Y equals x squared is the first one. All right, and there's my parent graph here, right? It's right down the middle there, and it's in red. And I also want to put y equals 3x squared. And let's see what happens now when I do this. Y equals 3x squared. All right, look at that blue one. It's kind of getting inside of that one a little more. All right, and what happens when we do y equals 8x squared? Well, let's see, y equals 8x squared. Oh my gosh, it's even more inside, right? It looks like those are getting a little more narrow every time this number is getting bigger. All right, and now what else? We have y equals 0.5x squared, or like a half. All right, let's see what happens now. y equals 0.5 x squared. Oh, there's that kind of a purplish color. Look at that. It's a little wider than my parent and then those other ones. All right. And how about y equals 0.25x squared? Y equals 0.25x squared, and it's in black here, right? And that's even wider than the other one. All right, so let me zoom out a little bit. Look at those graphs, okay? So I am going to take a little snippet of this, all right? And if you don't have that feature, that's fine. All right, so again, just reference my notes here. All right, and this time I'm going to include the equations and the graph here. All right, I'm going to throw these into the notes so you have these to reference. All right, there it is. And let's see if I can get this a little bigger. Ah, look at that. Okay, so there you go. All right, so here are the 5 different graphs. All right, and we can see kind of what happens every time either this number increases or is greater than 1. It kind of gets more narrow, and then as it gets less than 1, it gets wider. All right, so here we go. I just said it. All right, so what happens to our graph of y equals x squared when we went ahead and multiplied x squared by a constant greater than 1, right? Again, a constant is just a number greater than 1, right? It looks like it gets narrow as the a value gets bigger. All right, so as that number goes up, 3, 4, 5, 8, 10, 100, right, the more narrow the graph is going to be. So conversely, right, what happens to our graph of y equals x squared when you multiply x squared by a constant less than 1, right? Those are my fractions or my decimal, all right, is going to get wider as the a value gets smaller, right, as it approaches 0. All right, and that's going to be like my 0.5, my 0.25. All right, so that's going to be more wider than my parent graph. Okay, so now we're going to try and see what happens when I graph these quadratic functions using decimals. All right, and now look at my 3. I got my parent one of y equals x squared. I got y equals negative 3x squared and y equals negative 9x squared. All right, so I'm going to go ahead and clear these out. Actually, I could have kept my parent one in there, but that's okay. So you have y equals x squared. All right, again, there's my parent graph. And now I want to do y equals negative 3x squared. Y equals negative 3x squared. Ooh, look at that. Now it's kind of facing downward. All right, and now let's see y equals negative 9x squared. And look at that. That one's pointing down as well. Huh. Okay. So I think it's almost safe to say that when it's negative, right, my graph is going to be kind of pointing down. And you don't have to draw these graphs, so you can kind of do a rough sketch of the graph on your notes here. All right. Go ahead and erase that line. Oh no. Control Z, come back. All right, so let's move this piece and erase this piece. All right, and this seems in the way again. All right, so let's make this a little bit bigger so you can see it. All right, so now, right, what happens to that y equals ax squared when the constant a is negative, right? And we're going to say that it opens down. All right, so when that number in front of your x squared is negative, your graph is going to go ahead and open downward. Awesome. All right. So now we're going to see what happens to our quadratic equation when it looks like we're going to add something to it at the end here. All right. So I'm going to clear out these two and keep my parent. All right. So that's my parent of y equals x squared. And now I want to see what happens when I add 2 to that parent and when I add 5 to that parent. All right. And actually, you guys should probably take a guess. What do you think is going to happen when I add 2 to this? Well, let's see if your guess is right here. It looks like it went up 2 units. Is that what you guessed? All right, now let's see what happens when we add 5 to this graph. Y equals x squared plus 5. Oh, look at that. It went even higher up. All right, so look at that. It went way up here with my plus 5. It went way up and went here with my plus 2. So it looks like it's kind of being shifted upward a little bit. All right, let's take a picture of this. And we're going to put that in the notes here so you guys can reference this later. There we go. All right, so now let's fill this out here. Okay, so if you're writing your notes down here, all right, this is what you want to write down, all right, is when something is added to my x squared, all right, so when something is added, it's going to shift up that many units, right? It was plus 2, so I went up 2 units. The next one was plus 5, so I went up 5 units. All right, so now we're going to see what happens when we subtract numbers from my parent graph, all right? And I bet you can probably take a really good guess at what will happen now when we subtract these. All right, so I'm going to start over here. Y equals x, and open the keyboard for squared. And now we have y equals x squared, and we're going to say minus 1. Look at that. Did you guess I was going downward? I bet you did. Y equals x squared minus 6. All right, so it looks like it is being shifted downward that many units when we are subtracting a number from that x squared. Right. I'm going to put these images in the notes here, all right, so you guys can use those later when you guys start the homework. All right, so there you go. You can see what happens. Right, that was my parent. That minus 1 is a green one. It got shifted down 1 unit, and that minus 6 is this purple one, and it got shifted down that many units. And there's the clue. All right, so this is what you want to write down. All right, when the constant is being subtracted, it is going to shift down that many units. All right, it shifts down that many units. All right, we got one more set of graphs to look at here. All right, in example 5. All right, we're going to see what happens when we do this to our parent functions. All right, looks like these are going to be in parentheses with a plus 6 squared for that first one, and then in parentheses x minus 4 squared. Okay, we're going to see what happens to these graphs of the quadratic functions when I apply those two things to it. All right, so again, I'm going to start with my parent of y equals x squared. All right, and now you gotta be careful typing these in, all right? And look at the parentheses here. So we're gonna have y equals parentheses x plus 6 squared. So y equals parentheses x plus 6. All right, and we want the square now on the outside of our parentheses. Oh, look at that. All right, did you see where it went? When we added 6 to it, it looks like it went 6 units to the left here. Huh. So I wonder what happens when we're going to subtract a number inside my parentheses. All right, let's see. Y equals parentheses x minus 4 squared. X, I want that inside, right? X minus 4. Go ahead and move the cursor on the outside. Squared. And look at that blue one. It looks like it got shifted 4 units to the right. All right, so let's take a picture of this. And we're going to copy and paste that onto the notes here so you can use this to reference. All right. And there you go, right? So it looks like here's my parent in black, right? And when we added a number inside the parentheses, it shifted to the left. And when we subtracted a number inside the parentheses, it got shifted to the right that many units. So here we go. So what happens to the graph when a constant is added before squaring, right? Meaning it's in parentheses, right? That means it's going to be shifted to the left that many units, all right? Kind of acts opposite of what you think. Kind of like that point slope form that we talked about earlier this year. All right, so what happens to the graph of y equals x squared when the constant is subtracted before squaring, right, in parentheses, right? And it's going to be shifted to the right that many units. All right, again, if you're writing notes down, all right, so you want to maybe write this base example here and add it before squaring, it shifts left. And when you subtract before squaring, it shifts to the right. All right, so hopefully this makes some sense. All right, again, we're going to review all this stuff and the graphs all on Friday. All right, so try the practice homework. All right, I'm just going to have you guys match up some graphs based on this, and definitely you want to reference these notes here when you're doing the homework. And of course, email me if you have any questions. I'll be happy to meet with you before Friday.